surfaces. So the idea is that it's possible using nanotechnology to coat a surface to eliminate all reflections from surfaces. And this is a picture showing you a piece of silicon, which is our particular interest in our lab. We study solar cells. So you see a polished piece of silicon reflects a lot of light, about 40% of the light. And after applying this coating, the silicon is completely black. And you don't have to take my word for it. We actually have some out there, so stick around. You can come look at them. The reason it's black is that all the light that's hitting the silicon is going into the silicon, which is what you want in the solar cell. So I mentioned we're interested in solar cells, but you might imagine controlling reflections is something all of us should be interested in. Whether you want your windows to not reflect as much, or you're annoyed by the reflection off of your new Apple Watch. Any of these kind of things are places where glass makers and manufacturers try to control reflection. There are kind of military reasons why you might not want signals bouncing off of you as well. So if instead of coating a surface in this traditional way with an anti-reflective film, you would instead choose to coating a surface with something that looks like this. And this is our invention. This is a very close-up, highly magnified image of one of our surfaces and structured in this beautiful way using nanotechnology. It occurred to me that when I was talking to some of you earlier that you might not all fully appreciate this if you're not used to looking at nanotechnology. So what I'd like to emphasize to you is, first of all, the beauty of this, and secondly, the smallness of this. So you see this surface kind of has all these spikes on it, has these little balls on top, and you see I have a scale bar over there, which probably doesn't mean much to you because you don't think about nanotechnology that often. So what I'd like to emphasize to you, I'm going to compare the size of one of these balls to something that you are familiar with. So you think about a piece of dust. Think about the smallest piece of dust you can. And I chose talcum powder. So we know talcum powder is like tiny little dust, right? So I'm going to draw a picture now on this screen of what a piece of talcum powder dust looks like. So this gigantic ball, like sitting on the surface, is the same size as a piece of talcum powder. So the point is, this surface has been structured in a very small way. It's been structured purposely in this way to impart this high degree of anti-reflection, to turn a shiny piece of silicon completely black. Let me tell you about the competition. So we all know you can make water bead up on surfaces. You can go to Home Depot and buy turtle wax. We've been doing it for years. And you can make water bead up on your car. The water doesn't roll off, but it beads up. So there are ways to make things hydrophobic. Waxes, Teflon, things like that. There are ways, other competing things out there. There are a number of small guys trying to make a go of it. They all have their particular way of imparting this super hydrophobicity. You might have seen this great video lately on the New York Times website. People are cutting inside of ketchup bottles now with this stuff. And like there's a picture of ketchup just like, it's really amazing. So there are lots of people trying to make a go of it. Some differentiators for us. So I mentioned too, the smallness of our structure allows it to withstand higher pressures than any other bit that's out there. As well as our ability, the way we make these is integrated with a manufacturing infrastructure that already exists. And I'd also just like to point out one other thing. This relates to a question that you all may have about, could you really use this on a windshield? Maybe, maybe not. But let me also point out to you that because we are integrated with thin film manufacture, our method is very amenable to producing these structures in certain areas on surfaces versus others. And I'm particularly keen myself on kind of on-chip diagnostics, where you're kind of flowing water in little channels around on surfaces, more controlled environments, but where you really need to be able to pattern this slippery surface only in certain